Let's finish this one up. We looked at a related rates example yesterday, and we didn't quite get through it. I want to finish this up because there's something that comes up in this problem that you're going to see. Just to quickly review, we had an airplane which was flying horizontally on a path that took it directly over a radar dish. And what do we know about this? We knew that the distance S is decreasing at a rate of 400 miles per hour when the distance from the radar dish is 10 miles. Okay? And something I neglected, remember, to tell you was that we know that the plane is flying at a constant altitude of 6 miles, and that's important. And we were supposed to come up with the speed of this thing, right? Okay, so let's just go through our little checklist here, and we got our 4-step plan for solving a related rates problem. First one was draw the picture and identify what we might call the snapshot variable. So think of this as one frame in the movie. One frame in the movie of the plane flying along. And at this particular frame, what do we know? What are the values of all the quantities that were given? We said that, well, S was 10, right? So we wrote that down. And the fact that the distance S is decreasing at a rate of 400 miles per hour, now that's not a static thing, is it? That's something, that's a changing thing, right? That's a dynamic thing. That was S dot, right? The rate of change of distance, okay? And that shows up, we know it's an S dot if we look at the units. And I wrote those units in kind of maybe a bad way there. If we wrote those units in a more scientific way, it would have been 400 miles per hour. And the fact that there's an hour in the bottom, that's a dead giveaway that this is a dot, right? Because the dots are the rates of change with respect to time. So change in something always over change in time. In this case, change in distance over change in time. And the units are a giveaway a lot of times. You just look to the unit to see what kind of quantity this is. So, and it was because it was decreasing, we had to make that negative 400. And then we established that if we're looking for the speed of the plane, if we call the horizontal distance of the plane x, then that was just x dot, right? Speed is just x dot. Okay? And so there's our picture that we drew. We got all the units identified, or all the snapshot variables identified. Next step is we've got to come up with a parent equation, right? So if we just ignore the dots, we've got x's and s's up there, or the two variables if we ignore the dots. So we've got to come up with some static equation that relates those two things. Right? So in that snapshot there, nothing's moving. What is that going to be? Now, suggestion was made we could use sines and cosines and things, and we could, but the problem with that being we've got to introduce another variable, and we don't know anything about that variable, right? So we don't want to do that. We want to keep this as lean as we can, as few variables as possible. So we want to come up with hopefully just an equation that involves s's and x's, and once we got that 6 miles in there, it became pretty clear what was going on. It's just a right triangle. And so we're just using Pythagorean theorem. And this is just about where we left off. So we said x squared plus 6 squared equals s squared. There's our static equation. Once we get the parent equation, remember, all we got to do is then do the calculus. We're going to relate the rates by doing our implicit differentiation stuff. And so we took our static parent equation and we differentiated everything with respect to time. And we got our 2x x dot plus 0 equals 2s s dot. And if we solve that for x dot, which is what we're trying to find, this is our answer. Okay? Great. Now, does anybody see a problem with our answer there? Not an insurmountable problem, but a little problem. Let me scroll up here so you can see this is the stuff we know about, right? Ah, okay. Yeah, now we don't know x dot. That's okay. That's what we're trying to find. That's isolated. But the x dot is written in terms of s's, sure, that's fine, s dots, check, and x's. We don't know anything about x's, right? But could we go back and calculate something about x's? If we go back to our static picture, Yeah, we should be able to, shouldn't we? Right? If we go back to the static picture now and we're trying to plug in the snapshot variables into our final answer, we can start to go back and fill in some numbers here if we want to, right? Okay, so, because we're just plugging in numbers anyway. So if I want to solve for x, I can do that how? Pythagorean theorem, sure. If I know that s is 10, let's just write these in. If s is 10, and that's 6, well, this is a right triangle. Does anybody see what kind of right triangle that is? We know the answer. Say it again. Yeah, it's a 3, 4, 5 times 2, isn't it? So it's a 6, 8, 10. And we could get that through the Pythagorean theorem, but we know that's Builder's triangle, right? We know that those are the 3, 4, 5 are the ratios of a right triangle, special right triangle. And so we know then what we can add that little element there. X is 8. And now we can just plug and chug, right? Now we get S was 10, right? S dot was negative 400, and X was 8. Okay. And so if we do the math there, what are we going to get? 50, negative 500, right? Now they wanted. So what we really found was a velocity, wasn't it? We found a velocity because we said that this is increasing or it's decreasing, right? The s or x is changing at a negative rate. If the question technically was asking for speed, what would our answer be? 500. Yeah, positive. Yeah. We know that because it's traveling in this direction, the velocity makes it negative, but speed would be positive. Okay. Make sense? Okay. All right, I'll leave it up to you. Do you want to go through another one of those, or do you want to just go start practicing a little bit? I tend to think that would be good, because I'm sure we'll be back. I mean, you're going to run into some problems on 2 cents. I mean, hopefully not, but I anticipate it's pretty hard, but fun stuff.